So what we're going to do today is we're going to go work backwards. Instead of starting with parallel, today we're going to prove parallel. So we're going to start with congruences or supplementaryage, and we're going to go to parallelage. How would you write the converse of this? If two parallel lines are cut by a transversal, then corresponding angles are congruent. So like we said, we could flip this around in just normal notation here. Corresponding angles congruent. Then we have parallel. So how do I word that out and flesh it out? So it looks like this. If two lines are cut by a transversal and corresponding angles are congruent, then what do we get? The lines are parallel. So what's the hypothesis here? The hypothesis starts off with lines being cut by a transversal. But the most important part of that is that the corresponding angles are congruent. And where does it take me? It takes me to the conclusion that we have parallel lines. So in terms of concept, this is the converse. In terms of concept, this is the converse. Hence the name, corresponding angles converse. So if you want to refresh, all the converses that we talk about regarding corresponding angles, alternate interior angles, etc., the point of the converse is to show parallel. The point of the converse is to show parallel. So notice the converse again. Two lines are cut by a transversal and the alternate interior angles are congruent, then the lines are parallel. So as we look here, we start with the alternate interior angles are congruent. Let me clean that up. And that takes us to parallel. By the way, all of these take me to parallel, so I'm going to fill that out. Everything here takes me to parallel. Demonstrates parallelage. And if we wanted to shortcut these, we have alternate exterior angles congruent. And lastly, if we have consecutive interior angles are supplementary. Now, just as an addendum, we also have consecutive exterior angles are supplementary. Again, this one is not spoken of much at all, but it might show up. But logically, we see that it is also true. The proof for this one would be the same as all the other ones. Question. If you turn the page, what does this say? It says, is it possible to prove that the lines are parallel? And if so, explain how. So let's see here. Let's look at this diagram. How do we know if the lines are parallel? Well, if the lines were parallel, well, we don't actually need to know that. We do know something about this pair of angles here. What's their relationship? Please tell your neighbor. Good, so we have these pair are linear. So if I were to subtract from 180, I get 124 degrees. Oh, I see that somewhere else. Now, I have this angle being 124 and this one being 124. So what's true about corresponding angles? So since the corresponding angles are congruent, what's my conclusion? The lines are parallel.
58 plus 74 equals 132, and like that way they're corresponding angles. And if two lines are cut by transversal and corresponding angles are congruent, then the lines are parallel.
Great. So because of the corresponding angles, converse, these two puppies are congruent, and another, we could say that 132 is equal to the sum of the 58 and the 74. So the converse states that therefore the lines must be parallel. Holy high hurdles. Now let's take a gander over here. What we need to do here is double check that these two add up to something. Please tell your neighbor, what should everything add up to and why? Go. I know that when you woke up this morning you said, dear God, I hope we do proofs today, and I am here as an angel to answer your prayer. So It is true that both angels and angles are divine, and you can show that just simply by writing them. Angels, learn to spell. Holy hashtag, let me get that fixed here. Look at that, see how close it is? They're anagrams of each other, so clearly they are both divine. So if I were Dan Brown, I just proved it to you. We're going to write a two-column proof, and notice what we have. We do have a pair of parallel lines, but we're trying to prove that these two are parallel. Okay, so let's think about backwardage. Let's think about backwardage here. If I wanted to prove parallel for the red lines there, A and B, I would have to demonstrate that a pair of angles have a nice relationship. Well, how are 3 and 2 related when you are talking about A and B lines? Tell your neighbor, please. So we've worked backwards a little bit. So let's see here. We are told the two lines are parallel, which is given información. Now, notice, here's a time where I'm not writing the other given information down. Again, you have flexibility. You could put all the given information in one line. That's fine. But here we're splitting it up because we're not using the given yet. We start with the parallel. Since the lines are parallel, then I know that angles 1 and 2 have to be congruent because they're corresponding angles. So what reason do I write? You can either write corresponding angles postulate, or you can say with parallel lines, corresponding angles are congruent. Okay, next. Now we're told 1 and 2 are congruent, and when I look at the diagram, I don't see why they're congruent. They don't have a special relationship. So I first start here and say, holy snap rabbit, there's nothing that works. However, up here, it's given. So that's actually nothing I need to show much. I just write the word given here. So that's a context where I might write the given later on rather than just at the beginning, because now I'm going to use it. Because I figured out that 1 and 3 are congruent. I'm told 1 and 2 are congruent. Therefore, 2 and 3 have to be congruent because why, class? Transitive property. If you said substitution, that's fine in dandruff, but transitive would be the most distinct answer here. Okay, and lastly, since we've demonstrated that angles 2 and 3, this angle here and this angle here are congruent, we now know the lines have to be parallel because of what converse? Tell your neighbor, please. So in this case, we would say alternate exterior angles are congruent, therefore parallel. Or if you simply say the name, alternate exterior angles converse. What we can do is when we set up our proof, let's make a two-column proof like this. The top part says statement. If you want to just abbreviate with an ST, the whole universe knows exactly what you're talking about, so that's fine. Next, I'm just going to put an R over here instead of reasoning because I am all about going faster. Okay, so now, in this case, I'm going to actually follow the same pattern. I'm going to start with the parallelage with the given, and I'm not going to write down all the given, just that. Now I'm going to use it. Once I wrote it down, I'm going to use it. So since the lines are parallel, I now know a pair of angles, angle 1 and angle 3, are congruent. Now, by the way, as you write something in the over here in your two-column proof, or as you see something up there, it might be wise for you to be marking it over here in the diagram. So now let me go ahead and mark the parallel because I stated it. So those are parallel. Maybe a little bit more clear there. Okay, so now I know that angle 1 is congruent to angle 2. And the reason for that is when you have parallel lines, corresponding angles are congruent. All right, please tell your neighbor what's the next step that we can write and why are you choosing to write it now? Go. Make a quick change there. Angle 2, 3 there. This is angle 3. We can write down this and also give an información. Please keep yourself organized. Folks, notice that 1 is across from 1, 2 is across from 2. I know it's kind of crazy how things are matching like that. So if you have a hard time drawing or keeping things straight, make sure to be using your lined paper to help you out. All right, number 4. What did you write down there, please? And Amanda. Congruent now, too. Great, and the reason for that is the transitive property. And the last thing is what? Please whisper romantically to your neighbor. What is our conclusion? Congruent. Therefore, we have parallel lines.